We talk a lot about AI, software, models, hardware, but there's a massive, overlooked piece: energy. The explosive growth of AI is creating a real-world energy challenge, not just a software one. Hyperscale data centers are reshaping global power systems, consuming staggering amounts of electricity and forcing us to rethink our power infrastructure. Today, we're diving into how AI's energy demands are driving a revolution in the very infrastructure of the internet. This is the hidden story of AI's energy revolution. Let's get into it. When we think about AI's limits, we usually focus on algorithms or hardware. But the real bottleneck now is raw electrical power, watts. Training and running models like GPT-4 can use as much energy as a small city. Tech companies are choosing data center locations based on access to massive, stable power, straining aging grids. The future of AI depends on solving this energy challenge, not just making smarter software. It's a fundamental infrastructure problem that demands a new way of thinking. To meet these energy demands, data centers are evolving into active players in the energy ecosystem. They're integrating on-site power generation, solar, wind, even next-gen sources, becoming partially or fully independent from traditional grids. The data center is becoming the power plant of the digital age, managing, storing, and sometimes generating its own energy. This shift transforms data centers from grid liabilities into potential assets. It's a complete reimagining of critical infrastructure. The next step? Power-positive data centers, facilities that generate or enable more clean energy than they consume. Virtual power plants, VPPs, let data centers use their battery storage to support the grid, not just themselves. Some centers are built next to waste-to-energy plants, or are piloting small-scale nuclear reactors for constant carbon-free power. On-site solar and wind are expanding, making these centers anchors for cleaner, more resilient energy systems. Data centers are no longer just energy consumers. They're becoming key players in the energy transition. It's a radical transformation. Data center batteries used to be just backup power. Now, with AI-powered energy management, they're strategic assets for the entire grid. These systems predict solar output, optimize charging times, and monitor grid health in real time. Data centers can reduce consumption or feed power back to the grid, acting as shock absorbers for renewable heavy systems. AI-managed batteries are turning data centers into dynamic, responsive partners for grid stability. They're the intelligent glue holding tomorrow's energy systems together. Every watt powering a server becomes heat, traditionally wasted. Now, data centers are capturing that heat for district heating, warming homes, offices, and even pools. In places like Scandinavia, this is already happening, creating new revenue streams and low-carbon heating for communities. Waste heat can also support greenhouses or industrial processes, turning a liability into a valuable resource. Data centers are becoming integrated parts of local infrastructure, not just isolated tech hubs. It's industrial symbiosis in action. Combining on-site renewable smart batteries and heat reuse, data centers can drive economic growth without environmental trade-offs. These projects create tech, construction, engineering, and even agricultural jobs, all while supporting clean energy goals. Distributed energy resources make the grid more resilient and less dependent on centralized plants. The needs of tech and the planet are finally aligned. This is a blueprint for sustainable, broad-based economic development. This isn't just theory. It's a real blueprint for the future of digital and energy infrastructure. The book that inspired this video breaks down practical models for power-positive data centers, VPPs, and district heating. It offers step-by-step guidance for leaders, policymakers, and investors to build and fund these projects. The roadmap covers technical, financial, and policy strategies for sustainable growth. It's a comprehensive guide for building the new economy. To wrap up, AI's growth is now an energy and infrastructure story. Data centers are evolving into energy producers and stabilizers, driving a more distributed, resilient, and sustainable grid. The digital and energy economies are converging. They're now the same economy. The challenges are huge, but so are the opportunities for innovation. Let me know what you think in the comments and subscribe for more deep dives. Thanks for watching. See you next time.